This is an experiment on separating architecture from code. Comments and suggestions are welcome. In my mind, code is just a building material. System architecture is more important than code. In this video, I'll just show a simple technique for writing an architectural description and how to browse it in layers. Then we can look at the code to see how it maps to the design intent of the architect. I imagine that in the future we might invent several more precise languages to describe architecture, like the parts-based programming PBP stuff I describe elsewhere. But for this video, we'll just use English and some SVG pictures. What does this code do? To figure that out, we've become used to reading the code and reverse engineering why the architect wrote the code that way, and try to recreate the reference version of the parts-based programming PBP kernel. I'm inventing a meta language on the fly. It's intended to emit Python code and to emit code in other languages, like JavaScript, Odin, etc. This meta language is a lot like Python with braces, along with a few keywords that begin with the $sign and the @ sign. You don't actually need to understand the meta language at this point. I only want to show how to use layers to describe an architecture by spiraling into it in a layered manner. I've been writing comments in ASCII text to explain what's going on and what the metacode is meant to accomplish. But it would be easier to explain in stages than to use diagrams. I'm drawing SVG diagrams using Draw.io, and I've asked Claude to write Elisp code to align code and comments based on key bindings. Here's an interim snippet of metacode. The algorithm that I want to describe is called container handler. It takes one parameter self that's defined elsewhere. At level 2, we describe the purpose of this function. We are writing the algorithm for how to handle parts that are composed of other parts. This is kind of like Lisp lists that contain other lists. At layer 3, I say more about the algorithm. First, we punt the incoming message down to children parts. Then we cycle and step the innards of this container until all internal events have subsided. I use the word event here to mean an event which causes a reaction, a message event. Level 4, I choose to show red arrows for how to punt events down to children. The interesting point here is that one incoming event is copied twice and fanned out to 2 inner children. I think that the diagram shows what is happening better than words. At the next level, I say that the algorithm steps until quiescence, and show what I mean in the next level down. The diagram shows that the incoming event caused a reaction from 2 inner parts, which then sent 2 more events, which then generated 2 more events, which got fanned into the output of the composite part. Again, the diagram says this better than my words. Here, I've hit the key to show all architectural comments with code embedded within them. Here, I hit the toggle key to turn off all architectural comments, showing only the code. We already saw this code at the beginning of the presentation, but now we have a better idea of why the code was written this way. If I wanted to study the code some more, I could continue to hit hotkeys to turn on various architectural layers as needed.